listen, we are starting 1.8 today, and as a reminder, you need your laptops on Tuesday, okay? I'm going to keep reminding you until we get there, but you do need your laptops on Tuesday. You do not have school Monday. And I won't be here on Tuesday, as I told you. Hey guys, can you please stop talking? I will be here on Tuesday, like I told you guys yesterday. You will have an online quiz where you can work together, use your notes. I'll make sure my sub knows that. But it's an actual quiz grade. Unlike the progress check that we did, that was just a homework grade. This is an actual quiz. Okay, so you want to bring, of course, your notes and your laptops on Tuesday to do the quiz on College Board. Okay? And I will keep it open longer than just Tuesday in case you're absent or don't finish it in class. I think it's 10 questions. All right, so we are continuing on today with rational functions. We got introduced to them yesterday. We learned about horizontal asymptotes, slant asymptotes, and end behavior. Today we're still talking about end behavior. We're still talking about horizontal asymptotes, and we're going to introduce zeros and one other type of problem. Okay, so if you remember, vertical, horizontal, rational functions are a fraction with a poly on top and a poly on the bottom, like you can see here. And one new thing we're going to talk about today is you always get zeros from your numerator. What's another word for zeros? Somebody? X values. What else? Not Y. Never Y. X values. Zeros, x-intercepts, roots, solutions, okay? X-intercepts is really what I was gunning for there because these are related to a graph. We get the x-intercepts, zeros, from the numerator only, okay? So what we're going to do is find the zeros of this rational function, and we're going to state the end behavior, EB, okay? So Zach, unless you've watched the video yet, you probably won't know how to do some of this. So you probably need to go back and watch that when you get a chance. All right, so if my numerator, remember that's where I get my zeros from. If my numerator isn't factored, I have to factor it, okay? So whether you show the work for a chart, this is a chart problem, or not is up to you. Remember, I like to be very clear about what work I require. So I will always tell you, I don't need to see the work here, but if I do say that, that doesn't mean you can't show more work, okay? So I will never take points off because you showed work that's not required to show, okay? I hope you guys can look at this and not have to go off to the side and make a chart anymore, but if it helps you, go right ahead, okay? So the two numbers that multiply to get 12 and add to get 7 would be what? 4 and 3, does it matter what order I write them in? Of course not. So that's my numerator factored. Now, just for fun, let's just factor the denominator because it will be important tomorrow to factor both the numerator and the denominator. So I want to remind you that that's the difference of two squares, x plus 1, x minus 1. Although, when we look for our zeros, we only look to the numerator. These are our zeros. These are not zeros. Okay? They are called vertical asymptotes or holes. We will learn about that tomorrow. Okay? So if I set each of my numerators equal to 0 and solve, those would be my two zeros. If I graph that, which I'm not, my graph would touch the x-axis at -4 and -3. Okay? End behavior we learned about yesterday, and I told you that sometimes horizontal asymptotes are called end behavior asymptotes because they're tied together. And so what we learned yesterday, and even though this isn't asking for the HA, I'm going to find it because it's the same amount of work as if I were going to just find the end behavior. My horizontal asymptote in this one, remember we look at the degree of your numerator, the degree of our denominator. When they are the same, we then have to do something else, and that is look at the leading coefficients. Remember that? So 1 over 1 is just 1. And remember, horizontal asymptotes are always y equals something. So we know that our left and right end behavior is going to be approaching 1. Okay? So let's write our statements. The limit of our x as x approaches negative infinity, the left and the right. And we'll see it in this graph here in a second. to really sell this to you, how end behavior and HAs are related, but we are going to be approaching 1 from both directions because that's what our HA is. Okay? And that's it for that question. We're going to do the same 2 questions, same 2. We're going to find zeros, end behavior, but a couple other things, and use a graph to answer the next question. Okay? For the graph below, find the zeros, the HA, the end behavior, and the factor of the numerator. So I'm going to put it in a little bit of a different order. I'm going to put 0, and I don't know if there's 1 0, more than 1 0, I haven't looked. The factor or factors come directly from the 0, so I'm going to put that next. Then the HA is helpful to find in order to answer what the end behavior is. Okay, so I'm just getting myself organized. These are the things I need to pull off the graph. It's actually easier with a graph, in my opinion. There's no factoring or even doing any math. It's really looking at the graph and being able to tell what's going on there. So let's start with zeros. Looking at this graph, looking at this graph, remember the zeros are our x-intercepts. So where the graph touches the x-axis happens to be in just one spot, -3. Right? That's our zeros, the only place. Make that a factor. We've done this before too. Bring the -3 to the other side, it would become x plus 3. We should be able to toggle between zeros and factors in either direction, right? Just a second ago in example 1, we had 2 factors in our numerator. You guys didn't even think about it. You didn't like write it out. You set that equal to 0 in your head and that equal to 0 in your head, and you got the zeros. Go in reverse. I just move them back to the other side of the equation. Okay. Horizontal asymptote. We're not looking at degrees. We don't have this written in algebraic form. It's in graph form. So notice that dotted line where our graphs are getting really close to, but they're not going to cross them. Okay. What would we call our HA? What is it? I heard you guys say y equals 1. If you write 1, is that okay? No, we have to put y equals. Hey, it's always going to be HA is the y. Because it's a line. Horizontal lines always start with a y, like y equals 1, or y equals 6, or y equals -3. That's an imaginary line right there that you can see. Look at the graphs. They're getting, you can always, and we're going to see it in another one in a second, you should always be able to kind of tell by the behavior of your graph what you're getting really close to. And that's this horizontal line right here, which is called y equals 1. Now let's do our end behavior statements. So we need to know the name of this. It doesn't have a name. There's no name on this graph, f of x. So you call it whatever you want, okay? I'm going to call it Evan. Why not? Who cares? Why does it have to be so generic, like f of x or g of x? Maybe this graph's name is Evan. The limit of Evan as x approaches -infinity, and the limit of Evan as x approaches infinity. If someone just walked in the room right now, it's like my administrator to like observe me, he'd be like, I don't think she knows how to do this math. She's putting like people's names in there. Okay, and what are we going to put on the other side of the equal signs? 1, yeah. As the graph goes to the left and as the graph goes to the right, we're getting really, really, really close to 1. 1 is blocking it. We won't go up high. We won't go down low forever. A horizontal asymptote blocks our up and down movement. It won't let us go above it or below it. Okay? All right. Now, in these 2 examples, do you guys remember the infamous number 10 from the last test? The sign chart? Yeah, it's back. Okay, 1. You can't sleep in this class. They are back, okay? And the directions on how to do these is written out in 7 steps. I could read them to you, but I think that me especially, but I'm going to assume you guys too, learn better by watching someone do it. if you ever wanted to go back and read all of these, it's exactly what I'm going to be doing, which is stuff we've already done. There's really nothing new. So if you understood number 10 on the test, you didn't like, I mean, no one's like, ooh, those are fun, let's do more. It's not that it's difficult, it's just the steps, but hopefully it's getting easier, especially after today when we have to do more of those, okay? So I'm actually going to do example 4 first, because this is exactly like what we would have had on the test. This is not a rational function, right? There's no fraction here. It's just a regular old function, okay? And so to remind us how to do it, I am going to do an old one first. And so those directions at the top are going to tell you to get everybody onto one side, check. Everybody's on one side. Factor your polynomial or polynomials if there's 2 of them in a rational function, check. This is already factored for us. Now we find the critical values, okay? Remember, the critical values in this problem are all 3 zeros. So 1, 2, 4, right? Those are my critical values. And I'm going to set up my number line, least to greatest, and pick some test values. Now you can pick the same ones as me, you can pick different ones. Sometimes we have to use a decimal. And this is the worst part, right? We have to plug and chug. We have to. Some of you are good at doing this math in your head. Some of you need to pick up your calculator. I'm guessing that's where some of the annoyance comes in, right? If you have to type everything in. So maybe try to do it without a calculator, except on a test maybe. You want to be really sure. But when I plug a 0 minus 1 in, I get a negative. 0 minus 2 is also negative. 0 minus 4, negative. Right? They're all negative. A negative times a negative times a negative is negative. What are we looking for? Less than or equal to 0. So we want anything that has a negative in it. So we know that is going to be part of our solution. Good? 1.5 minus 1. 1.5 is greater than 1, so it's going to give me a positive answer. 1.5 minus 2, that's negative. 1.5 minus 4 will also be negative. What? Nope, 1.5 minus 1 would be positive. Oh, is that what you were asking? You weren't questioning this? Oh, okay, okay. So positive times a negative is negative, and a negative times a negative is positive. Yeah, it's positive. Is that what you were asking, Jocelyn? Are we on the same page, you and I? Okay, good. Sorry, I kind of got distracted. 3 minus 1, positive. 3 minus 2, positive. 3 minus 4, negative. This will give us a negative. We like the negatives. And 5 minus 1, positive. 5 minus 2, positive. 5 minus 4, positive. 3 positives make a positive. Okay? Now, especially today, but definitely before, brackets and parentheses make a difference. It matters if you use parentheses or brackets, okay? So, if you have the equal to sign under it, we use brackets. Without the parenthesis, without the equal to sign, we use parentheses, okay, in our answer. Let's take it a step further, and this is going to help us when we get to ones with fractions. Trust me, it will. Sometimes it's smart to put some symbols on our critical values on the number line, so when we go to write our answer, it's very clear. Because we would use brackets for this question, right, all of these are less than or equal to, you could like show a closed circle on all 3 of these zeros. So a closed circle on a number line is the same as a bracket, which is the same as putting an equal to sign. It's included in the solution. Whereas if I put an open circle, that would have meant that this was just a less than or a greater than. And I would know when I go to write my answer right now that I would put brackets on these, okay? I shouldn't have written that. That looks terrible. All right, so my answer is from negative infinity all the way up to 1. And I see that closed circle there, so I'm going to remember to put a bracket. You can put a comma, you can put a union symbol, and then again a bracket 2 to 4. So I promise I will come back to why that's going to be helpful to put that on the x-axis, our testing numbers and all that in a second, okay? All right, so that's like what number 10 would have been like on your test, all right? Let's do one of the new types of functions, rational function. Easy to tell it's a rational function because it's a fraction, okay? But it's actually easier, in my opinion, okay? Because it's on a graph. We're going to answer this question using a graph. So there's no factoring, there's no testing, it's visual. It's all visual. Okay? So, in the directions it says solve the inequality r of x is greater than or equal to 0 by using the graph. So, just so I don't have to write it again, I'm just going to say it like that. Okay? In the directions it said r of x, which is this, is greater than or equal to 0. So, let's take a look at our graph. So if you guys remember at the beginning of class, I was kind of talking to Evan about like those asymptotes and things like that. They're not labeled on here, but I want you guys to notice that there are 2 vertical asymptotes on this graph, and we should be able to start telling that, and this is brand new this year, probably talked about last year, but by looking at the behavior of the graph, can you guys tell where you might have, or where we, not might, where we do have vertical asymptotes? Anybody see the first one? Good, yes. So at -3, there's an imaginary line, and we'll learn all about it tomorrow, the vertical asymptote, similar to a horizontal asymptote. You can't cross it. Your graph is getting closer to it. Do you guys see the other one? 3, yeah. So if you wanted to label your graph as such, you could. And what this is asking for, guys, is where is this graph, which is right here, greater than or equal to 0. So there's nothing to the left of that asymptote. We're below 0. All of our points are below 0. In the middle, though, you can see we are greater than 0. This is 0 right here, right? We are greater than 0 or equal to 0 all the way to 2, right? That's equal to 0 right there. And all of the rest of it is greater than 0. What is keeping us from going to the left is that -3. So from -3 to 2 is the first interval of the x-axis that we are above or equal to 0. How I use my parentheses or brackets matter. If you're an asymptote, you are never part of the solution. Sorry about that. We are approaching -3 on the x-axis, and we're going up forever, okay? But what's the x doing? It's getting as close as it can to -3, but remember, because it's an asymptote, you can't touch it and you can't cross it. So we don't include it. That's everything to the right of -3 is included. And what do you think we're going to put for 2? It's asking for any of the numbers that are greater than or equal to. 2 is equal to 0, right? It's on the x-axis, so it is part of our solution. If that symbol had been just if it had just been greater than, it would have been a parentheses here, okay? And then this piece of the graph also. But notice the arrow. It's not crossing down like this one did. This one went down. This one is going from 3 to positive infinity. Now, we always know infinity symbols are going to have parentheses. What are we going to put on the positive 3? Parentheses, because it's an asymptote. You can't touch an asymptote. If you are an asymptote, you're always going to have parentheses or an open circle. You are not part of the answer. You are a boundary that says, you can't touch me. If you can't touch me, you're not included in the answer, okay? All right, stay with me. We are going to do one more example, which is really the newest stuff today. This is exactly like example 4a that we did a second ago, except it's not a regular old function, it's a rational, okay? So all the steps in the beginning are the same. Get everybody over to one side, check. Factor everything. Thank you very much. It's already factored. Then we find our critical values, okay? Critical values are the zeros in the numerator, so 3 and -2. Those are my zeros, right? Got some multiplicity there, but still, those are the only two places our graph will touch the x-axis. And even though the denominator is not a 0, it is considered a critical value. I just showed you in that last example how stuff happens at those asymptotes. They're important. They block us. You're going to learn tomorrow that x minus 2 gives us a vertical asymptote at x equals 2. So even though it's not a 0, it is a critical value, okay? So let's go ahead and set up our axis, our x-axis. Remember, you always put your numbers in order from least to greatest. And I'm going to go, this is really the only added part of this problem, is I'm going to just set up the x-axis with open or closed circles to make my answering easier. So listen here. If you are in the numerator, you're a 0. And if it says greater than or equal to, just like we did on the last one, the one we did here, we had closed circles on all of our zeros because it had the equal to sign under it, okay? Same thing with our zeros here. If there's an equal sign underneath it, you're going to have a closed circle on those zeros. The zeros were here and here, right? So at 3, we'll have a closed circle, which means bracket. And at -2, we'll have a closed circle because it's included in the numerator. If you are in the denominator, 100% of the time, you will be using a parentheses because that is a asymptote. You can't touch it. So it's just like we said, if you're approaching these two imaginary lines, we use parentheses. Same thing here, it's in the denominator. That means it's not part of the solution because you get a 0 in your denominator. That's not allowed, all right? What if, guys, just what if, real quick, what if the problem was this symbol instead of that? What would the -2 and the 3 have on them? Open circles. So if this isn't a less than or a greater than, and it has a denominator, everything's open. There's no brackets at all. When will we use brackets? Only on our numerator if it's got the equal to sign. Yes, Evan? No. Change them? No. Well, I went from factors to zeros. These are factored form. You set them equal to 0 and solve them. So I set x minus 3 equal to 0 and got 3. Set x plus 2 equal to 0 and solved it at -2. Set x minus 2 equal to 0. So yeah, you have to find the zeros of your factors. All right, let's pick some numbers. -3, 0, yucky. Now, so here's where we get annoyed, right? This is annoying. But let me tell you something. When I plug a -3 into that first parentheses, I get a negative. No matter what I plug into this factor, it's always going to be positive. When you square a positive number, you get a positive answer. If I square a negative number, I get a positive answer. So don't even waste time on that one. It's always going to be positive. And then a -3 in the denominator, that's negative. So a negative times a positive is negative. Negative divided by a negative, positive. Is that part of my solution? Yes. Greater than or equal to 0 is positive numbers. Okay? Next one. 0 minus 3, negative. 0 plus 2 squared, always going to be positive. 0 minus 2, negative. This will get us a positive. So negative times a positive is negative. Negative divided by negative is positive. So this is also a part of the solution. That can happen. We're used to kind of seeing every other, but it can happen where you have more than one area adjacent to each other. Okay, 2.5 minus 3, negative. 2.5 plus 2 squared, always going to be positive, not bothering with it. 2.5 minus 2 is positive. This would give us a negative. We don't want any negatives. 4 minus 3, positive. 4 plus 2 squared, always going to be positive, not messing with it. 4 minus 2, positive. All those positives. And now because we did the work in the beginning, it's really easy to just read our number line and give our answer. So from negative infinity all the way up to 2. Open circle on the 2 means a parentheses on my 2. Then we go to 3 to infinity. Always use parentheses on infinity symbols, and I have a closed-in circle on the 3, so it would be a bracket. So you guys can maybe think ahead, now that you've had a test in this class, a multiple choice question would have lots of variations maybe of this answer. It would cut down on the amount of work. You might even be able to get away with just making the number line and knowing what's open circle, closed circle, so you can pick the right answer that has brackets and parentheses. Do you see what I'm saying? So you could make this really work for you if you understand how to get around doing some work. But it would be easy to get the whole problem wrong because you picked the one with a bracket on the 2 or something like that. So you have to be very careful. All right. We are going to go to the homework now, and I'm going to do a bunch with you. Okay. I'm going to take this down. Anybody saw that? Omit means do not do. Okay. It's just fewer letters. So if you want to do number 4, maybe don't cross it out right now because I will put the key on Canvas. So it might be one you want to practice. I could have kept it in there. I was just feeling nice this morning because first period I had 1,700 students tardy. So annoyed. And classes cut short because of mental health. Yeah. If you must, if you must. All right, let us get started. I'm going to do number 1, 2, 3, and I think 8 or something with you. All right, so find the zeros and the end behavior. Okay. Zeros come from your numerator only. So I'm going to set my numerator equal to 0. That's one that I might have to show some work. It depends on if you can do that math in your head or not. But I'm just going to set it equal to 0 and solve it. I would subtract 4, divide by -2. We have 1, 0. That would be our x-intercept. Sorry? Zeros only come from the numerator. Remember the very first example we did? Yeah. Okay. Critical values includes the zeros, but it's not only zeros. Good, Jocelyn. You worked that through in your head. All right, and then the end behavior has to do with our HA. Didn't ask for the HA, but we're going to need to know to do it, and it gives us our end behavior. So let's just look. Remember, you take your leading terms. My leading term on top would be -2x. My leading term on the bottom would be x. That's the same. Remember, degree of the numerator is the same as the degree of the numerator. Then you look at the numbers in front. So -2 over 1 would be -2. So my horizontal asymptote would be y equals -2. Now I know what my end behavior is to the left and to the right. It's -2. So let's go ahead and write it. The limit of f of x and the order you write your end behavior statements is completely up to you. I always put negative first, then positive. Just be careful if it was like a fill in the blank or a multiple choice test or something. Always be careful to make sure you're picking the right answer, that the negative infinity and the infinity matches your answer, because it might be given to you out of order. I think it's mean to do that, but it can happen. And then what am I going to put after each of the equal signs? -2. All right, let's do the next one. To find the zeros, we need to factor. The first step of all factoring is to factor out a GCF. That makes this problem so much easier. Now it's an easy chart problem. You don't have to do the bring down the outside 2 or anything, so always remember to look for a GCF first. So we're looking for 2 numbers that multiply to get -8, add to get -2. Where's my good factors? What? What 2? 4 and 2. Positive, negative, does it matter? Can you just throw 4 and 2 around like nobody's business? -4, +2. If you need to make the chart and, try things on your calculator, that's your prerogative, okay? Go right ahead. But you have to know how to do that, guys, okay? So Evan, these are my factors. Set them equal to 0 and solve gets me my zeros. So my zeros would be 4 and -2. Okay, factored form is with the parentheses, then you set your factors equal to 0. If I set 3 equal to 0, guys, you can't solve that. 3 is a factor, but it's not an x, it doesn't have an x in it. You only get solutions from your x's, just not in real life. Okay? End behavior is going to come from our HA. It didn't ask for the HA, but it's easy to find. So degrees are the same, so we look at the leading coefficients. 3/1 would be 3. So we know our end behavior is 3 on both sides. Okay. Yeah. Yes. When we start doing, I think maybe tomorrow or what's tomorrow? Tomorrow or next Wednesday in section 1.9, when we approach, you're not always going to approach negative infinity. You might approach 3 from the left and 7 from the right or something weird like that. You'll see. But yes, they can be different. They were before. Sometimes we had infinity and negative infinity, right? Like different infinity, negative. So they can be different, but on these they aren't, which is kind of nice. Okay, let's do the next. I said number 4 is optional. Up to you if you want to do it or not. Find the zeros, the factors. The HA, I'm just reading the directions and pulling off all the things that we need to find. Okay, so looking at the graph, our zeros are our x-intercepts. There's one there, there's one there. And I can't see, so let me look at the key. Another way to write, and I like to always show you lots of different ways of writing things. You can still do the x equals, but you might see that. Remember, those fancy brackets are called your solution set. So the solutions, what are my zeros? -1 and 4. Or you could write x equals -1 and 4, whatever, okay? So make those factors. If those are my zeros, my factors would be x plus 1 and x minus 4, right? We should be able to toggle between zeros and factors back and forth. That's right. So if they're already set equal to 0 and solved, you just go back up to the other side of the equal sign. All right, what is our horizontal asymptote visually? Do you guys see it? It's y equals 1. Remember, on an FRQ, if you just wrote 1, you'd get it wrong. So that's why I'm really hammering it into your brain. Let's make sure we are writing y equals 1. And now we know our end behavior, right? Our end behavior is going to be 1 left and right. We just have to write it out. I'm going to call this graph y because it doesn't have a name. I will put the key up for number 4 if you want to practice another one, just like that. Okay. But I'm going to go on to number 8 with you. And then I'll give you a few minutes to, well, we'll probably just go ahead and do the mental health thing, and then you'll have a lot of time. It'll probably be the only class that can finish in class. Say it again. 11:04. Is that right? No, sorry, 10:17. Oh yeah, that's really long. Okay, so here's one of the newest types. Everybody's on the left-hand side. It's already factored. Great, thank you very much. Critical values, Jocelyn, the numerator is our 0, but that denominator is a critical value, not a 0. Okay? Critical values include anything where stuff happens on a graph, which are the zeros and the asymptotes. Because these are in factored form. What's the 0? Right? Well, don't think about it as changing signs. This is factored form. How do I find the solution? I have to set it equal to 0 and solve it, okay? So I'm just setting each of my factors equal to 0 and solving them, and that gives me -2 and 4, okay? So these are factored form, these are 0 or solutions. Okay, so just 2 numbers. Anything that comes from the denominator is going to be an open circle. That's the 4. If it's in the denominator, it is going to be an open circle, which is going to translate to use parentheses in my answer. If you're in the numerator and it has the equal to sign, it would be closed. But if the equal to sign weren't there, it would also be open. All right? So -3 plus 2 is negative. -3 minus 4 is also negative. Negative divided by negative is positive. We want numbers less than 0. That is not less than 0. 0 plus 2, positive. 0 minus 4, negative. That would give me a negative. Yep, we'll keep you. And then plugging in 5 plus 2 is positive. 5 minus 4 is positive. Not part of our solution. Our final answer, bracket, because of the closed circle, parentheses, because of the open circle. Okay. It says less than, what's less than 0? Negative numbers. If it was greater than, you'd be going for the positives. Greater than 0 would be positive. Okay? Lots of good questions, guys. Now, I know you are having so much fun with this.